So this is a review for Unit 1. What I'm going to do is have the practice test here. I'm going to kind of review each section, kind of go through an example of each one. So hopefully we can clear up any questions you might be having from Unit 1. So when we look at the first section, the instructions are to write an equation of the line and interpret the slope. So to do this, and on the test they're going to ask you also to interpret the Y-intercept, but it's fairly easy. These are linear equations, and so the first thing I'm going to decide is that it's linear. And remember that linear tells us that that is y equals mx plus b, where m is our slope and b is our y-intercept. All right? And then remember, slope is, to find slope, our equation is y2 minus y1 over x2 minus x1, where y's, remember, are the second values of our ordered pair and x's are the first one. It doesn't make any difference which one you call the first set or which one you call the second, as long as you keep them together. So I'm going to look at number 2, and this chart says that it's home sales and then years after 1995. And you can see that they give us the ordered pair 1 600 and 5 200. So I'm going to be using our slope-intercept form, and the first thing I'm going to do is take our ordered pairs, which are 1 600 and 5 200. So those are the two ordered pairs that they've given us. And we're going to then plug them into the formula to find the slope. Again, it doesn't make any difference which one you use, you just have to pick one. So I'm going to call this our second set. So this is x2, y2, and x1, y1, and we plug it into the equation. So that would be 200 minus 600 divided by 5 minus 1. So we get a negative 400 divided by negative 4. And so that gives us a slope of, if I divide that, of, positive 4. So that would give me a slope of negative 100. So we've got our slope at negative 100. So now we go back to the problem that we've got here, and we have to find the y-intercept. So we now go to our equation for slope-intercept form. We can pick either of these ordered pairs for x and y. I'm going to go ahead and choose this one. And so we plug it in, and so y is 600. So I'm plugging it into this formula. So 600 equals, we know our slope is negative 100. And then our x value we're using is 1 plus b. And so if I plug that in, I get 600 equals a negative 100 plus b. Add 100 to both sides, and we get 700 equals b. And so I've found my slope-intercept, or my y-intercept. And so now I can write my equation as y equals a negative 100x plus 700. So that would be our equation for this line. Now they ask us to interpret the slope. Well, the slope is a negative 100. When they ask you to interpret the slope, you're interpreting it for the chart. So again, this is home sales in millions. So this tells us that our slope, the sales are going down 100 every year. So if I was going to determine this, I would just say that sales are decreasing. Now, this is 100, but remember this is 100 million, so it's really decreasing $100 million every year. Now, if they ask you to determine the y-intercept, which is what they will do at the on the test, is, well, our y-intercept is 700, and so if we go back to the chart, that's telling us by this problem that we started with $700 million in sales. So that would be for the problems 1 through 3. Again, use slope-intercept form, use the ordered pairs to find the slope, plug it in to find the y-intercept into the formula using one of the ordered pairs, and that should take you through those problems. The second set of problems on here is 4 through 7. And on 4 through 7, this is solving a system of equations. So, to solve a system of equations, the first thing we want to do is line up all like terms. Okay? So as we look at this equation, these equations, we want to make sure the x's, the y's, and the z's are all lined up underneath each other. The second thing we want to do, because we're going to use elimination, is to let's do this. Choose one variable to eliminate. Okay, so when I do that, I look at the problem and I decide it doesn't really make any difference which one you choose to get rid of. We want to get rid of the x, the y, or the z. But what I usually do is I look at the problem and I say, well, what's the first thing they all go into? So as an example, if I was to look at this one, the first thing that the x's all go into is 3. The first things the y's all go into is 6. And then the z's, the first thing they all go into is 6. So I would choose the x's probably because they have the smallest number. The only thing on this one is you see there's no y. And so if I was going to line these up, I would move this y, the z over so I had it all lined up. So I might get rid of the y's because I can do that really quickly in this one. I only have one to get rid of. But you want to get opposites. So we choose a variable to eliminate. The next thing we do is make the variables opposite in two equations. So we've got to get those equations down so that they're opposite each other. And so then once I have it where I have opposites, so we're going to choose two equations. Get opposites. Add together. Because if I take opposites and I add them together, they'll eliminate that variable. So we'll do that once, and then repeat with two different equations. So what that does is it gets us down to two equations with two variables. Then we take the two remaining equations and repeat process to remove another variable. So what's going to happen is we're going to start with three equations and three variables. We're going to get down to two equations with two variables. And then by doing this, we'll get down to one equation with one variable. And then you will solve for the remaining variable. So that'll get us an answer for one variable. Substitute that answer into one of the two equations with two variables. and solve for the other variable. That will get us down to where we have two answers. And then lastly, substitute those two answers into one of the original equations to solve for last variable. So now we'll have all three variables solved for, and then the last thing I would advise doing is check in another equation. So hopefully you've got all these notes written down. You can pause it at any time to get that. And then what we'll do now is we'll go through one of the problems so you can see how that's done. So I'm going to do number 5. So if I write that equation down, we get 3x plus 5y plus 4z equals 13. 5x plus 2y plus 3z equals negative 9. And 6x plus 3y plus 4z equals negative 8. So we have to choose a variable to get rid of. Again, you can do any one you want. I just try and find the one with the smallest number. So if I start with the x's, the first thing those go into is 30. First thing these go into is 30. And the first thing the z's go into is 12. So I'm going to choose to remove the z's because they have the smallest number they all go into. So I'm going to number these equations 1, 2, and 3. And we just have to pick two of them. I'm going to pick 1 and 3 because the z's are the same in this case. And what I'm going to do then is take the first equation and I'm going to multiply it by a negative 1. So that just tells me to take this whole thing and multiply everything by a negative 1. So I get negative 3x minus 5y minus 4z equals negative 13. And the bottom equation stays the same, 6x plus 3y plus 4z equals negative 8. And we add those together, and we get 3x minus 2y equals negative 21. So now I need to use two of these other equations to get down. We got one equation with two variables, we need another one. So we can use any combination, we just don't use 1 and 3 again. So in this case, I'm going to use 1 and 2, and I'm going to multiply to get opposites. I want 1 to be 12 and 1 to be negative 12. So I'm going to multiply the top equation by a negative 3 to get negative 12, and I'm going to multiply the second equation by 4 to get a positive 12. And so we go negative 3 times 3x is a negative 9x minus 15y minus 12z equals negative 39. And then 4 times the second equation, so we get 20x plus 8y plus 12z equals negative 36. And when I add those together, I get 11x minus 7y, the z's cancel, and we get a negative 75. So now I have two equations with two variables, and now I need to get down to one equation with one variable. So again, I'm going to get opposites, and I'm going to make the y's opposite because they both go into 14. So that means I'm going to have to multiply this first equation by 7. So 21x minus 14y equals a negative 147. and I'm going to multiply this next equation. I want that to be a positive 14. And so I'm going to multiply that by negative 2. So that gives me a negative 22x, a positive 14y, and a positive 150. And so now I add those together, so I get negative x equals a positive 3. And so now I just multiply both sides by a negative 1 to solve for x. And we get x equals a negative 3. So I found one variable, x equals negative 3. So now I'm going to take that x equals negative 3, and I'm going to plug it back into one of these two equations. Doesn't make any difference which one. I'm going to choose this one. So I take the 3, and when I come to x, I replace it with negative 3. Minus 2y equals negative 21. So 3 times negative 3 is a negative 9. Minus 2y equals negative 21. Now we got to solve for y, so I'm going to add 9 to both sides. So negative 2y equals negative 12. Divide by negative 2, and so y equals 6. So now we know x and y, and so now I just have to find z. So I plug those into any one of my 3 original equations. Doesn't make any difference which one. I'm going to choose the first one. So I'm going to go 3, and when I come to x, I'm going to replace it with negative 3, plus 5. And when I come to y, I replace that with 6, plus 4z equals 13. And now I solve for z. So 3 times negative 3 is negative 9. 5 times 6 is 30. Plus 4z equals 13. Combine like terms. So I get 21 plus 4z equals 13. Subtract 21. So 4z equals negative 8. Divide by 4. And we get z equals negative 2. And so our answer, which is written as a ordered triple, what's called an ordered triple, and you always put them in alphabetical order. So our x is negative 3, our y is 6, and our z is negative 2. If I did it correctly. So now what we want to do is just really quickly check this. So I'm going to go back to my second equation now, and I'm going to check that and see if it works in that. So when I'm going to have 5, and when I come to x, I replace it with negative 3, and then plus 2, and when I come to y, I replace that with 6, plus 3, and when I come to z, I replace it with negative 2, and if we've done this correctly, it should equal negative 9. So 5 times negative 3 is negative 15, 2 times 6 is 12, 3 times 2 is a negative 6, and so negative 15 plus 12 is a negative 3, minus 6 is a negative 9. And so it works out that it checks, and so I know that I've got it right. And so my answer is written as an ordered triple. We use parentheses here just like we do with an ordered pair. And so it's negative 3, 6, and negative 2. So that is how you do problems 4, 5, 6, and 7. Okay, those are all three variables, 3 equations. Some of them, like this one, only has 2 variables in it. So like on that, I would get rid of the y's first. If you ever have a case where the variables cancel, but like if I added them together, let's say that I had 4x plus 2y equals 8, and I had negative 4x minus 2y equals negative 8. Well, when I add those together, I get 0, 0, 0. If you get the case where the left side and right side are equal, then that would be all real numbers work. Okay, I can plug anything in and it will work. Actually, a better way to put it would be to put infinite solutions, because the intersection would be a line. So let's do that as infinite solutions. And then if by chance this would have been a negative 9 and I get negative 1 where they're not equal, Well, if it's not true, then that means there is no solution that works for it. All right? So if the variables cancel, the left side and the right side are equal, it would be infinite solutions. If the left side and right side are not equal, then it's no solution. So the next part of the test is working on, it says match the transformation with its graph, then write a rule for the graph. So what we have to understand on this is transformations. So for transformations, I'm going to go through all the rules up here on the smartboard. Again, a pause. So, transformations. First thing we need to understand is we're working with functions, and we have lots of different functions we work with in this chapter. The three that are on the test are linear functions, absolute value functions, and quadratic functions. All right, so linear functions, remember, if we talk about the parent function, it's the simplest function we can have. And so that would be y equals x. Now, you can graph this. If we were to make a chart, 0, when I plug in 0, I get out 0. When I plug in 1, I get out 1. When I plug in 2, I get out 2. When I plug in -1, I get out -1. When I plug in -2, I get out -2. And so that gives us a graph that runs something like this. And that would be our parent function. Again, it's the parent because there's nothing added or subtracted to the x, it's all by itself. So that would be our simplest function. With absolute value, our simplest function is y equals the absolute value of x. Now remember, absolute value is distance from 0, so whatever comes out of here cannot be negative, and else there's negative signs outside, but the value of what's in here is going to be positive. And so if we were to make a chart for this, when I plug in 0, I get out 0. When I plug in 1, I get out 1. When I plug in 2, I get out 2. If I plug in -1, though, the absolute value of -1 would be 1, and the absolute value of -2 would be 2. And so our graph in this case is going to look something like this. It will always give you either a V or a TP if it's flipped over. And then the last one we're going to deal with is a quadratic function, and our parent function for that would simply be x squared. And so again, if I was to make a chart, at 0, I'm at 0, 1 squared is 1, 2 squared is 4. If I plug in -1, well, a -1 times a -1 is a +1, and a -2 times a -2 is a +4. And so our graph of a parabola gives us our graph of a quadratic gives us a parabola, and so it's going to look something like this. Okay? And so those are our parent functions. And on the test, they're going to ask you to graph the parent functions. You need to know what those parent functions are, and then you can easily plug in numbers to get the graphs. So now we need to talk about transformations of these. So transformations. Transformations are ways we can, remember, we can adjust what these graphs look like. We can move them left, right, up, down. We can stretch them. We can shrink them. There's lots of things we can do. We can reflect them over the x and y axis. But it's really important that you understand that there are two ways these transformations run. They can be horizontal or vertical. Remember, remember, vertical is up and down transformations, and horizontal is left and right transformations. So we've got these transformations that can be up and down, left and right. And there's different things we can do. The first thing we can do for both of these are reflections. So reflections are simply a negative sign. And the same thing over here. The difference between the vertical reflection and the horizontal reflection is a vertical reflection, again, is up and down, so that flips it over the x-axis. Whereas horizontal is a left to right flip, and so that's over the y-axis. So this would be over the x-axis, and this would be over the y-axis. The other difference is that you have to remember is vertical things affect the whole function. So as an example, if we have the function 3x plus 1 as a linear function, since it's a reflection over the x-axis, it affects the whole thing. And so that would mean I would take and write it like this, and so that would be negative 3x minus 1. Whereas a horizontal, they only affect just the x. So if we take that same function, let's write this as a function f of x equals. If I had f of x equals 3x plus 1 over here, now this negative sign just affects the x. So really what I'm doing is I'm changing it to this. And then again I simplify this, and so it would be negative 3x plus 1. And so that's the difference between vertical and horizontal. Vertical affects the whole function, so I take a negative sign and adjust it to the whole thing. And over here it just affects the x, so the negative sign just goes to the x. And then in both cases I simplify it out as far as possible. So that would be reflections. So next let's do translations. Okay, translations are slides. And again, if it's vertical, which we're doing over here, that moves it up and down, and horizontal moves it left and right. So let's take this same function, f of x equals 3x plus 1, and now let's go up 7. So remember, if it's vertical, it affects the whole function. So that means I'm going to take this whole function, and I'm going to add 7 to it. And so simplify that, and I get 3x plus 8, and that would be our new function. Again, you can use any letters you want. You just need to change it because it's not the same function it was. And now let's do this one, right 7. So now remember, anytime it's horizontal, our function is f of x equals 3x plus 1. It just affects the x. And here's what you have to remember about horizontal. It's always the inverse of what it says. So when we're adding, when it's right or left, that's addition or subtraction. That's the additive inverse, which is the opposite. So since this is right 7, you would think that'd be plus 7, but it actually becomes the opposite of that. And so it becomes 3, and then again, it just affects the x. And then if I wanted to simplify that, that would be 3x. And then minus 21 plus 1 would be a minus 20. And that would be what our new function would simplify to. So that's translations. And then the last thing that we did was stretches and compression, or shrinks. So stretches and shrinks, just like when we had up here, this is always for translations. These are always addition or subtraction. Stretches and shrinks are multiplication. Okay? So if we go back to that first function we did, f of x equals 3x plus 1. So stretches are when the value is greater than 1, and shrinks are when the value is less than 1. Same thing over here. Greater than 1, less than 1. Now we don't worry about the negative signs because remember the negative sign is the reflection. So if it says, if it had a negative 3 in front, that's a reflection and that's a vertical stretch of 3. So anyway, as we go to do this, let's do a stretch of 2, a vertical stretch of 2. So again, remember, vertical always affects the whole thing. So I take the whole thing and I multiply it by 2. And so that would be 6x plus 2 would be our new function. If it was a shrink, let's say of 1/4, then I would take 1/4 times the whole thing. And so that would be 3/4 x plus 1/4 if I simplified it. Horizontal, again, just affects the x, and again, it's always the inverse. And so it's multiplication, it's the multiplicative inverse, which is also known as the reciprocal. You just flip it over. So here's where you have to be careful. So now if I do a stretch of 2, now this would be if I did a horizontal stretch. Again, if we use that same first function, remember it's always the inverse of what it says, so it just affects the x, so I'm going to put that in parentheses, but I have to take the inverse of this, or reciprocal, which would be 1/2 x plus 1. And so this would become 3/2 x plus 1. And if I did a shrink, of 1/4, again, because it's horizontal, it just affects the x. But I do the inverse of this, which would be 4x plus 1, and so we get 12x plus 1. So that's all the transformations we had. To summarize this, here's what you have to remember. We have vertical and we have horizontal. Okay? This is up and down. This is left and right. Okay? Horizontal is always the inverse of what is said. Okay? It's also affects only x. With vertical, it's whatever number it says it is, but it affects the whole function. Or you could just say it affects f of x, which is the whole thing. All right? Remember, negative signs are reflections. Addition, subtraction is up and down or left and right, and that's vertical, horizontal. And stretches and shrinks. Stretches are greater than 1, shrinks are less than 1. And again, we don't need to worry about the negative signs. So if we go back to the test, what it asks you to do on 8, 9, and 10 it asks you to match the transformation of f of x equals x with its graph, and then write a rule for g, which is the new function. So, if we look at this, first of all, let's examine the parent function. Remember, these are all linear. If you look at them, it's f of x equals x. That's the linear function and the parent function of that. And so if we were to look at that graph, remember, that would look like this. And so now what you want to do is look at these functions, and they want you to match it with the graph. So I'm going to do number 10. Okay, if you look at number 10, it says, remember, our parent function is f of x equals x, and they want us to match this with these down here and then write the rule. So when I look at this, the negative sign, since it is outside of the function, it affects the whole thing, so now I know that that is vertical, and vertical reflects over the x-axis, so now this parent function graph we know is going to flip over and go this way. And then the plus 4 again affects the whole function, so that tells me to slide it up 4. And so if I was to go to the graph, it would go up to here and then still run this way, and that's what my new one should look like. So as I look at these graphs, well, this one is going up, which I know has to be wrong because it was reflected over the x-axis. This graph, these are a little hard to tell, but that crosses between 4 and 6. These numbers are by 2s. And this one crosses at 4. So I know my slope-intercept, that has to be this function. And so 10 would match up with C. And then they asked me to write the rule for the function. Well, the rule for the function simply says I'm going to take the original and I'm going to reflect it. So we've got our original is f of x equals x. And we're going to reflect it over the x-axis, which tells me I'm going to multiply that by a negative sign. I'm also going to do a vertical stretch of 5, so I'm going to multiply the whole thing by 5. And then I'm going to do a translation up 4, which means I'm going to add 4 to the whole thing that I've got now. So I'm going to add 4. And they ask us to write that as the rule of g, and so it's g of x. So these are pretty easy because they just put f of x in it. All you have to do when you have these is you can just plug in whatever f of x is in for that. So in this case, it's pretty easy because I'm just taking this negative 5 f of x plus 4, and I just plug in x for f of x. And it's done. If we went to a more complicated problem, let's say f of x was equal to 2x plus 3, and now I did this exact same function, negative 5 times f of x plus 4, what I would do is when I came, I'd go negative 5, and when I came to f of x, okay, when I came to f of x here, I would replace it with the 2x plus 3, and then add 4. And then I would have to simplify that. So I put the 2x plus 3 in for the f of x, and then I would simplify that and get negative 10x minus 15 plus 4 is negative 10x minus 11. And that would be my new function, g of x. So that would be if it was more complicated. These are fairly easy because f of x is just x, and so you just plug it in. Number 11 is a story problem. It's just like 4, 5, 6, and 7. What I would recommend with story problems is that you read through the problem. So in this case, it says a local grocery store makes a 9-pound mixture of trail mix. The trail mix contains raisins, sunflower seeds, and chocolate-covered peanuts. The raisins cost $2 per pound. The sunflower seeds cost $1 per pound. And the chocolate-covered peanuts cost $1.50 per pound. The mixture calls for twice as many raisins as sunflower seeds. The total cost of the mixture is $14.50. How much of each ingredient did the store use? So, I've read through the problem. Now I want to decide what I'm trying to find, which is how much of each ingredient did the store use. So I'm going to label these, and we have, in this case, we have raisins, we have sunflower seeds, and we have chocolate-covered peanuts. So I decided what values I'm looking for, and I just have to assign values to this. So I'm just going to go x, y, and z. And now I look at the problem, and it says we're going to make a 9-pound mixture. And this is how much we're doing of each. So we know that x plus y plus z has to add up to 9. So that gives me one equation. Then it said that they go through the cost, and the raisins cost $2 per pound. So 2x plus the sunflower seeds cost $1 per pound, and then the chocolate covered peanuts cost $1.50 per pound. And we know the total cost is of what we're going to buy is $14.50. And so that gives me a second equation. And then the last one, it tells us that the mixture has twice as many raisins as sunflower seeds. So that means raisins is twice as much as sunflower seeds. So my last equation is x equals 2y. So now I have 3 equations for 3 variables. And so now I just have to decide which one I'm going to solve for. So again, I always recommend that you line stuff up. So I'm going to go x plus y plus z equals 9. 2x plus y, I'm just going to drop the 1, plus 1.5z equals 1450. And then I'm going to move the 2y to this side by subtracting and go x minus 2y equals 0 to get everything lined up. And so if I was doing this, I would get rid of the z's first because there is no z in this problem. But this is just like the problems we had on 4 through 7, and so you should be able to take it from there. But that's just an idea of how to set up story problems. So on the back, 12 through 15, it asks you to graph the function and its parent function and then describe the transformation. So when you go to graph these, again, the key is you have to understand the parent functions, which we went through earlier. This is linear, so this would be f of x equals, the parent function would be f of x equals x. This is absolute value, so f of x equals the absolute value of x. And quadratic, so f of x equals x squared. So you have to graph the parent functions and then these new functions. Again, you can make charts or you can use the transformations. But then you have to describe the transformations. Well, we went through all the transformations. So I'm just going to go through number 14 and give you an example of what I would expect to see on this. So we have to graph the parent function, which I already know. At 0, I'm at 0. At 1, I'm at 1. At 2, these are by 2, so at 2, I'm at 4. And at negative 2, I'm at 4. So this is going to be something to this effect. Okay? Then we have a negative 1/3. Well, the negative sign tells me it's going to flip over. So if I went to my chart that we had for parent function, it was 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. Now I'm going to do it with this. So again, I'm going to plug in those same numbers. Actually, I'm going to change it a little bit because this is a 1/3 and I don't want to deal with fractions. So I'm going to use 0. I still get 0. But I'm going to plug in 3. Because when I plug in 3, 3 squared is 9. And so I get negative 1/3 times 9, which would be a negative 9/3 or negative 3. And so when I plug in negative 3, again, negative 3 squared is still 9, so I'm going to get the same thing out. And so this function is going to be at 0, 0. At 3, I'm going to be at negative 3, so approximately there. And at negative 3, I'm going to be at negative 3. And so you can see that this gets a little bit wider. These graphs don't have to be perfect. But again, if we talk about our transformations, remember the negative sign reflects it, and it's affected the whole function, not just the x, because it's outside. So that would be a vertical, so it would read, I would put here reflects over x-axis. And then the 1/3, remember, that again affected the whole thing. It wasn't, if it just affected the x, it would have to be written like this with the squared outside. Okay? So if it was written this way with the 1/3 x inside, then that would be horizontal. But since it's outside the x squared, it's vertical. And so vertical, remember, is what it says it is. So that would be a vertical shrink, because it's less than 1, of 1/3. And again, we don't worry about the negative sign. If that would have been a -3, that would be a vertical stretch of 3. So that's what you need to put on 12 through 14. You have to draw both graphs, and you have to tell the transformations. So on the next one, 15, the table below shows the amount of fuel left in your RV while driving. What type of function can you use to model this data? Estimate the amount of fuel in your tank after driving for 90 minutes. So remember, to tell what type of function we have, if it's linear, which is what these are going to be, the change in y has to be the same as the change in x. So this went down 2, this went down 2, this went down 2, this went down 2. Now, it's not that just this is the same, the top has to be the same too. So this went up 20, up 20, up 20, up 20. So now, we know it's linear, so we can go back and do it just like we did 1 through 3. You can use any of those ordered pairs to find the slope, or you can just use what we have here. We know it's going down 2, and it's going up 20. Or it says it's going, change in y is -2, and the change in x is +20, which is a -1/10. So that's our slope. It's -1/10. And then you could do it like we did 1 through 3 to find b. But remember, b is the y-intercept, and the y-intercept, if I look at any y-intercept, it's where it crosses the y-axis, so that's when x is 0. Well, I know x is 0. When x is 0, it's at 18. So I know b is 18, so I can write that equation. So then we get our equation, y equals -1/10 x plus 18. And then it says estimate the amount of fuel in your tank after driving 90 minutes. Well, remember, x is our minutes, so we would just plug 90 in for x, and you can solve that. Then we get into transformations again on these last 4. So it says, write a function g that represents the indicated transformation of the graph of f. So we've got, I'm going to take 17. This is our function we have to start with. And it asks us to do a vertical stretch of 3. Well, we know that vertical affects the whole thing. And so that would tell us to take 3 and multiply it by the whole thing. And so when I multiply 3 times 2/3, well, that would be 6/3, or the 3's cancel, so we get 2x squared. So g of x equals 2x squared, and then 3 times 2 is 6, and we get +6. And so that would be transformations, and that reviews all of Unit 1. That should help you on any of the assignments that we have. That should also give you enough review so that you can go through and complete the practice test. If you don't have the practice test, again, you can go back and see the problems as you watch the video and do them on a separate piece of paper. Then come in and we can check that. I gave the answers in class. We went through that in class, so if you don't have those, I can have you check it when you get it done. So hopefully that helped you with Unit 1, and you'll be prepared to take that test. Thanks.